Hello and welcome everyone. We're so excited to have you all here today for our weekly OCI Deep Dive. For those of you who might be new to these events, we're hosted on Cloud Customer Connect, which is our Oracle community forum for end users. You'll see links in the chat throughout the presentation today that lead you back to those CCC forums, and we invite you to create a free account, join in discussions, look for upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today I'm joined by Greg Verstraeten, Senior Principal Product Manager, and Mickey Boxell, Principal Product Manager here at OCI. Today they'll take you through a typical journey of a Kubernetes cluster and show you how Oracle Container Engine for Kubernetes can simplify using that. I think that is quite enough from me. So go ahead and take it away, Greg. The floor is all yours.
Thank you. So this is our safe harbor statement. Don't make any purchase decision based on what we say.
And you're not sharing it.
I'm not sharing my screen right now.
Yeah, not yet. Yes, it's good now. Thanks.
It works. Okay. All right. So I want to start with this slide that shows the Kubernetes cluster architecture. So everyone is on the same page. Kubernetes is a application containerized orchestration platform, and it enables you to run your application and operate your application at scale. So this is the overall architecture of a Kubernetes cluster. It's made of a control plane that runs multiple components and a data plane, which are nodes that are executing the containers. So of course you can take Kubernetes and run it. Provision compute instances, set up your network, and run it. It is fairly complicated to install first and to operate. So to make it easy, we have a service that is called OCI, and it's the full name is Oracle Container Engine for Kubernetes, and it enables you to first provision your clusters very easily and operate it with simplicity. And we provision the clusters with all the security knobs available. So when you use OCI to provision your clusters, you have the control plane that is fully managed by Oracle. So your Kubernetes API is available and served by the control plane. This part you don't have to worry about it. It's all provisioned by Oracle and managed by Oracle. And then I've got the pause that keeps popping up. and then you have the data plane, and that's something that you own. The nodes that are provisioned as part of your data plane are provision for you, but this is something that you manage. Your applications are going to be executed by this data plane. And as a user of your Kubernetes cluster, so user administrators, you interact either directly with the Kubernetes API served by your control plane, or you use the CLI, the Kubernetes CLI that is called kubectl or kubectl to interact with your API. And of course, it can also be a CI/CD pipeline that interacts with your cluster. So I want to go through several points of how the benefits that you get with OCI. So first, it's So first, you get a pure Kubernetes experience. This is our first principle for the service. What you get is Kubernetes unmodified. Our service is certified Kubernetes conformant by the CNCF. And so you don't get a forked experience of Kubernetes. It's the pure experience. So whatever runs in other Kubernetes clusters would run on OKE. Any application that is made for Kubernetes would be compatible with OKE. The registry the container registry that runs side by side with OKE, where you would store your container images, is certified by the Open Container Initiative. It's compliant by the Open Container Initiative. You get advanced security with OKE. So OKE is engineered from the ground up with security as a key guiding principle. For example, OKE is integrated with services, part of OCI, of Oracle Cloud Infrastructure, to enable this security. So, for example, we integrate with identity and access management of OCI that ensure that your users that you manage as part of IAM can log into your cluster. And you have an integration with Kubernetes RBAC, for example, to restrict them to what they can do in your cluster. We have integration with networking, our VCN, virtual cloud network, to restrict the access to your cluster. With this, we can do private clusters, for example, clusters that are not accessible from the internet. They can be accessed only from within your VCN or from your on-premise network. We have image scanning and signing. So your images, you might want to make sure that they are not running any vulnerabilities, and you want to make sure that before those images are deployed in your cluster, that they are being scanned and removed from those vulnerabilities before they are deployed in your clusters. And OKE is compliant with industry standard certifications such as FedRAMP, HIPAA, SOC. OKE benefits from OCI Gen 2 infrastructure, which brings you the best performance. So first, OCI doesn't use any overcommitment of CPU. When you get a CPU for your compute instances, you get dedicated cores. You don't have over committed network. So when you run your application on OKE with OCI, you get the best performance. In addition, you have a rich catalog of shapes, HPC for high performance computing shapes. You get GPU shapes to run machine learning or video processing workloads. You get ARM processor architecture processors for your shapes. And for all of this, you can choose between bare metal servers and virtual machines. OKE is available in all OCI regions in the world. And in addition, you can choose to sign for a dedicated region and have OK in this dedicated region. OK is highly available by default, and we take advantage of the architecture of OCI. Your region might be organized in different availability domain and for sure fault domain, and OK takes advantage of this. So the control plane is spread by default between among multiple availability domains, and if you're running your cluster in a region with on a single availability domain, it's spread across multiple fault domains. And your control plane, where your applications are running, then it's up to you. You control where among which availability domain and fault domain it spreads. We bring a new feature. We brought a new feature recently. It's called the Node Doctor, and it aims at helping you bring a diagnostic of what would go wrong in your cluster. As I said earlier, Kubernetes is pretty hard to operate, and with OK we make it easy for you to manage it. And Node Doctor is there for this. It tells you exactly what doesn't go as planned in your cluster, what might be what has to be fixed in your cluster to run optimally. And finally, using OCI in general helps you reduce your costs. You get the best price performance for your compute shapes. You get flexible shapes that enables you to really size your compute instances to exactly what your application requires. And in addition, OK doesn't bring you any additional cost. The control plane of your cluster is free, and you only pay for the compute instances that run in your data plane, the storage that your application use, and the load balancers. So in this webcast, we wanted to really go through the features by showing you this, showing you the console, the OCI console. So I'm going to switch to the console right now, and there's multiple points that I want to make. I want to tell you about the private clusters, the encryption all across your clusters. The network security groups to restrict, control the access to your cluster components. The signed images, we already talked a little bit about it, and the Kubernetes RBAC integration with OCI IAM. So let me switch windows now. Manish, can you see my browser?
Yes, I can, Greg.
Okay, thank you. So this is the OCI console, and I'm going to the OCI console. That's in developer services, Kubernetes clusters. So when you start, when you go to OKE for the first time, all you get is create cluster. This is the first step. And there you have two options: either quick create or custom create. Let's have a look at both of them. So quick create, you get minimal options. It's meant to get you to create your cluster quickly without asking yourself a lot of questions. You give a name for your cluster, which compartment it should be in your Kubernetes version, and then whether your Kubernetes API endpoint is private or public. And then your worker nodes that constitute your data plane, whether they're private or public. Then a shape for those worker nodes, and E3 Flex is a shape that's where, as I said earlier, you exactly specify what's the number of CPU you want, and the memory that you want for those nodes. So again, it's a way to save cost, because you exactly control how much CPU and memory you assign to them. And finally, the number of nodes. So this is a very easy way to create a cluster. But I want to go through all the options with you. So I'm going to cancel this and choose custom create instead. With custom create, I've got all the control on all the options that are available for me with OK. So I've got a series I've got to go through a series of screens. The first one is just general information about the cluster. The name, let's call it cluster 1. The compartments in which it's going to run. Hopefully, I'm assuming you know what's a compartment, but for those who don't know, it's a separation within your tenancy to run your resources. So here, and in that, for compartments, you can allow your users to create resources in one compartment, but not others. It's similar in Kubernetes to a namespace, where I would allow users to deploy application in a namespace and not others. And then the Kubernetes version that I want to install. I've got some advanced features, advanced options to select, and here I've got the image verification. Image verification is what I was explaining earlier. I want to make sure that the application that are deployed in my cluster are verified, check that they don't contain any known vulnerabilities, and that they are approved to be deployed. If I want this, I need to select a key, an encryption key, to sign those images. So here I've got an integration with OCI Vault. OCI Vault is the OCI service that allows you to manage your keys, your encryption keys. It can be software-based Vault or HSM based hardware backed by hardware. So if I check this, I will be sure that the images that are deployed in my cluster are signed with the same key. Any other images will not be able to be deployed. Then I've got the choice of encryption for the Kubernetes secrets. So Kubernetes secrets is a feature of Kubernetes. The secrets are, for example, passwords, certs that are SSL certs that would be used in the clusters. Any kind of secrets would be stored as Kubernetes secrets. And physically, they live in components in a control plane called the etcd. By default, Oracle encrypts all data in OCI, and Oracle manages the key for the keys for all those data. But you might want to manage the key yourself for the secrets and for other data. And so for this, you would select this option, encrypt with a key that you manage. And again, select the vault that you would use and the key for to encrypt the secrets. And finally, here on this screen, you can set up pod security policies. It's a Kubernetes feature that is going to be replaced with something else in the future. But for now, it's still supported, and you can enable it in here. That requires you to change the admission controller for your cluster. I go to the next screen, and that's about networking. So here I'm going to select the VCN. VCN is a virtual cloud network that I'm going to use for my cluster, and the different subnets for the different components for the different touch point of the cluster. So first, let's select a VCN. It's prepared ahead of time. Now I'm going to select a subnet for the Kubernetes service type load balancers. So a Kubernetes service is a way to expose your applications to the outside world. Can be internet, it can be your own network, it can be only the VCN, it can be your own on-prem network. When I create a Kubernetes service type load balancer, it provisions an OCI load balancer, and so I need a subnet to provision this load balancer. So I'm going to choose a subnet that is public for this. So here we imagine that we're going to deploy applications that will be exposed to the internet. And next, I'm going to select a subnet for my Kubernetes API endpoint. You remember the Kubernetes API endpoint is the main endpoint with which you're going to interact, to deploy your application, to monitor your applications, to update them. All this is going through the Kubernetes API. And so the safest thing is to make this private, right? I want to make sure that I control who has where the access to this API is happening. So I want to make it from my own VCN or from your on-prem network. So to make a cluster private, that would be the choice. Here, for simplicity, I'm going to choose public, so I don't have to have any control in place to access it. I can select NSG for this to further control access to this API endpoint. And NSG is a set of security rules. And finally, when I set it public, I can optionally assign a public IP to this endpoint, so I can really access it from internet. Then I'm selecting the node pools that will be part of my cluster. So the node pools is, think of it of the data plane. That's where the containerized applications are running. I select an image, a number of nodes, the shape, similar to what we saw with a quick create cluster, in a version of Kubernetes to run on the node pool. And then you remember that you control the availability of your data plane, right? So if I want to spread it in multiple AD for maximum availability, that's where I'm going to I'm setting it up. So here I've got three nodes in my node pool, and I'm going to spread it across. I'm going to spread those nodes across all the availability domains. And then I select a regional subnet for each one of them. It's the same subnet. It's just that I can also have
Greg,
AD specific subnets. Yeah.
Can you zoom in a little bit?
Oh yeah.
Thank you.
So here I've got all my AD selected and the subnet selected. All right, and the last screen is about to summarize everything. And now, if I do create cluster, it's going to go through the provisioning of the cluster and then the provisioning of the nodes. And after this, everything is ready to be used. So I've got I already have it created for sake of time. And so when you create when the cluster is created, you have this dashboard where you can do the operations. The main one is accessing the cluster, and that's where you're going to generate the kubeconfig file that will be used by kubectl. You remember this CLI to access your cluster. We generate the config for this CLI automatically. So it can be through Cloud Shell or through your local terminal. So by executing those commands and assuming that OCI CLI is configured for your tenancy, you will have the kube config generated. Then I need to control who has access to my clusters, to my cluster, right? So for this, I'm going to go in IAM and define multiple groups. So I've got a group of administrators who will have full access to my Kubernetes clusters, but also some developers that are going to deploy applications. And so those developers, I will likely restrict them in what they will be able to do in the cluster. For example, I might want a group of developers to have access to a specific namespace and not others. So I create this group. I put the users that I would have defined in there. And here I've got my OCID, the ID for this group. That's what I'm going to take. I copy it and I'm gonna use it to configure. I'm gonna share my terminal now. I'm going to use it to configure Kubernetes RBAC. So everything in Kubernetes is in a form of a manifest, right? And so I'm going to configure this group of users to have a role in my cluster. I'm going to build a manifest like this, and this one shows enables a group of creates a role to read pods. So I can get, watch, list pods, resources pods in the namespace kube system. And then I'm going to bind that role to a group, to an OCI group, and that's the OCI that I captured earlier to be. Oh, I was showing the wrong group earlier, but it's I take the OCI of the group that I defined in OCI IAM and bind it to this role. So now, as a user, I will connect to the cluster with kubectl or directly through the API, and all I will be able to do is to list the pods on this in the namespace kube system. I'm showing this here. kubectl get pods in the namespace kube system. Will get me the list of pods in that namespace. Now, if I change my command and I run this, I want to list the services, for example. I'm not authorized for that, so I'm not. I don't. It doesn't work. I'm forbidden. Okay. How are we doing on time? Do I have to speed up?
We have about 10 minutes left.
Okay. Cluster is created. You need to operate it in the long term. So for this, we simplify some of the aspect of the day to operations. So first, we provide an easy way to set up logging, and all your logs can go in OCI logging, where you can search them, or you can use the logging server of your choice. We support Fluentd on the worker nodes that make it easy to. It's an open source component that enables you to configure sending the logs to either OCI logging or any logging server of your choice. We include the monitoring metrics in your OCI dashboard, and again, you can complement it with Prometheus and the Grafana dashboard. As I said earlier, everything you get a pure Kubernetes experience, right? So whatever system you have today, or whatever is made for Kubernetes, is compatible with OCI. And last, we have the audit system. So every audit event that is emitted by your Kubernetes control plane goes in OCI audit. So you can see who's logging into your cluster, what is going on between the different components. Everything can be retrieved from OCI audit. And now that we have a cluster ready, it's ready for day two operations. We are ready to have the developers deploy their application. And so for that, I would like my colleague Miki to show you some of those application deployments.
Thanks, Greg. Do you mind if I take over screen share?
Yeah.
All right, cool. Hey, everybody. This is Mickey. I am another OKE PM. I will be playing the role of the developer for the next few minutes. So what I wanted to show you today was I have two clusters, one with an application already deployed and one where I'll be deploying the application. Most of this is going to be in command line, and then as soon as the application is deployed, we'll actually jump in and poke around it for a moment. So to begin with, I'll just, let's see, make sure that I'm in the right cluster. So I'm going to change my context. This matches the cluster 2 that we just saw in the console here. I'm going to be using Helm to deploy the application. As Greg mentioned, OKE is compatible with a lot of different open source Kubernetes projects. OKE itself is a CNCF conformant version of Kubernetes, which means that we're unforked, and every single time a new Kubernetes version is released, we make sure to support it on our platform within a predetermined period of time. So because of that, that means that all these different cool open source tools that are built to run on Kubernetes also can be run on OKE, which is just Oracle's flavor of Kubernetes. So I'll begin by using Helm. Helm essentially allows you to package up a number of Kubernetes manifests being the way that you deploy things, objects to a Kubernetes cluster. And it allows you to package them up, change variables in multiple simultaneously, and then also manage things like version control or perform rollbacks. So in this case, I've created a namespace called MuShop Utilities. And I'm going to just begin by deploying my dependencies to this namespace. So when I say dependencies here, what I'm talking about are a number of pods or services that are required for this application to properly run. So I'll give this a second. And while that's happening, I'll grab the next command. And since this is a live demo, I am not surprised if I'll run into a hiccup or two, but the good thing is that I have this deployed in another cluster already. And in the interest of time, I may actually just jump over to that other cluster just to show you what this looks like. So when deploying applications to Kubernetes, it is kind of a new model, but what we do at Oracle isn't any different from what you do at another Kubernetes provider. So with this command, we're assuming that I'm a user with admin level access. As Greg mentioned previously, it's very easy to scope down the access to your users. So he could restrict me, if he's my cluster admin, to only have access to particular namespaces, only have access to read or write, basically just scope down the permissions that I have when it comes to interacting with the cluster. In this case, I basically have the same level of access that he does as an admin, although if this were a real world scenario, I would probably have it scoped down to be something more appropriate for a developer. You can see on this page that there are a number of different things that are already deployed to the cluster. So for example, I have an Nginx deployment, which is being used for my ingress. I have my OCI service operator controller manager, which is simply something that's used to proxy a bunch of OCI services. Core DNS is being used for DNS routing. I also have my CSI deployed. CSI is a container storage interface that allows me to do things like connect to OCI storage. Flannel is my CNI. But then if I get down here to MuShop Utilities and MuShop, I can actually see the meat of my application. So in this case, this is just a sample application. In fact, it's something that if I jump into the browser, I can share the setup steps with you right now. And anyway, so I can see that I also have some number of Kubernetes best practices already implemented with this sample application. So for example, I have a cert manager. I have Grafana, which is just simply a tool for visualizing metrics data from within my cluster. I have that Nginx ingress controller that's allowing me to have a public endpoint for this cluster, so you can access the application yourself, even if this were deployed in an otherwise private environment. I also have things like Prometheus node exporter, which is going to export export metrics from my nodes. So those are all part of the MuShop utilities namespace. But if I jump down to the MuShop namespace, I can see the different components of my application. So here I can see my API, other assets, can see my carts, which is a carts feature that's part of this microservice application, my orders feature as well. And anyway, all we're trying to show here is just one example of a sort of decomposed microservice application that can be deployed onto a Kubernetes environment. Now, something else I want to show is just how tightly integrated some of this is with OCI. So within Kubernetes, we have this concept of something called a persistent volume claim. And a PVC is a request for storage by a user. In the case of OKE, this dynamically uses OCI block storage. So what I can show you here is, let's see, just all the different PVs that I currently have in this environment. So each one of these is going to correspond to a block volume created within Oracle Cloud Infrastructure. Similarly, if I wanted to, if I wanted to get all of the load balancers that are created by Kubernetes, this is another point of tight integration between Kubernetes and OCI. I could get my services. Services is simply just the term used by Kubernetes for exposing things like a network endpoint. And I could, let's see, I'm going to make sure I get it from all namespaces. And then I'm going to grep for load balancer because that's the type that I'm looking for right now. Oops.
You missed a grep.
Yes, I did. Second try. It's hard to grep when you're not grepping. And anyway, what this will pop up with is the public IP address that's been associated with my application. So I'll actually just, let's see, go ahead and toss this in the chat, assuming I can highlight it properly. And if you like, you can all go here right now and see the application that we've deployed. Oops, and thank you, sending it to everyone. So here, you can basically just see that like this is a very powerful tool. I mean, I know that the application wasn't exactly deployed live, but this was deployed in just a few minutes with literally that one command that I showed, the Helm deploy. And then I suppose a second command to deploy the backend utilities, but if you're really so inclined, you could lump those two together. But anyway, we're talking about having like a pretty full-featured e-commerce application that was deployed in a matter of seconds. And of course, there's going to be a lot of effort that goes into actually building this application before you deploy it, and then maintaining it after you deploy it, and other best practices that come into managing the application. But the idea here is that we're just showing you that the process from getting up and running with a Kubernetes cluster, from when you start off by creating the cluster itself, sort of delegating access to things, and then actually deploying an application isn't going to take you very much time. And the nice thing is that the operational management for it is taken care of for you. And what I mean by that is, you don't really need to understand the underlying compute shapes that are running underneath. You don't have to really worry about the nodes very much. Those are things that are automatically provisioned by Oracle based on the preferences that you set. One other thing I wanted to share, just because I know we have a couple minutes left, are just the features that are available for additional security. So as I mentioned, this application is deployed using normal Kubernetes concepts. Each part of this application is running as a pod in a Kubernetes cluster. And a pod is simply the sort of smallest unit of measurement in Kubernetes. A pod really just runs a container or multiple containers, which all need to be scheduled on the same node together. So containers or container images are the actual sort of meat of the application. And those are where you're running the packaged up application images that you've already put together. Those, as Greg mentioned, can be stored in our container registry service, OCIR. And when they're in that service, you can do cool things like you can scan them to see whether or not there are any CVEs present. So in this case, I have a container that didn't have any CVEs, any vulnerabilities present. But if I go to this MuShop fulfillment container, which again, if I hop back here for 1 sec, I can see corresponds to one of the pods that I have running in my cluster. So I should, in a moment, see the fulfillment one. So right here. So if I go and analyze that image, I can see that, maybe its scan results are not that good. And then, in fact, I have 17 critical risks that have been found. And if I want to, I can even get more detail about the vulnerabilities that were discovered there. And the reason I bring that up is because what you can actually do is, if you want, you can prevent your cluster from deploying images like this. And the way that you would do that is by adding this additional verification step that we call attestation, where you associate a key and a signature with your image. And then you can set a policy on your cluster to only deploy images that have that matching signature. And in this case, that signature would just correspond to a cluster or an image, that you would deem to be healthy and then appropriate to deploy onto the cluster. And the way that you do that is by going to this image verification page, enabling image verification policies in the cluster, and then choosing which key you want to require images be signed with in order to be deployed. All right, well, I know I just rushed through a lot of information in not a very long period of time. If you're interested in more, please feel free to ask for us to come back to this call. And now that I've wrapped up my portion, I think we might have one more survey question to pop up, unless that already was shared.
Yeah, while the poll is being shown, we do have a couple of questions, Mickey, for your section that you covered. Excellent demo and presentation, both Greg and Mickey. Thanks for doing it. I can take those questions if you don't mind.
Yeah, sure. I'll take a look at the open ones. Okay, so
Sure.
One question was, is it possible to see the Kate's manifest of this demo application? So actually, I can do you one better. And if you wanted to deploy the application yourself, you can go to that page that I just answered in the chat. This is fully open source. This is actually like a very cool, sorry, when I say this, I mean MuShop is a very cool like full-featured demo application, a reference application that we built to run on OCI. There's versions of it that will use all of the OCI features, so you can actually provision everything from an autonomous transaction processing database to store state, to also things like API gateways, email notifications, functions, stuff like that. So it's a very cool tool to just sort of get more familiar with deploying microservice applications in the cloud. See, another question, does logging cover things like the Kubernetes API server? So logging comes in a lot of different flavors in the container world. You're going to see things like application logs, which are just deployed to standard out. Those can be captured as custom logs. Audit captures things in the Kubernetes API server. We are actually currently in the process of building out a new feature to capture all of the other service logs. And when we say service logs, those are logs that are part of Kubernetes API, but then also part of the Kube Controller Manager, the Cloud Controller Manager, and a few other pieces that customers normally don't have access to. I see there's a question from Deepak. The best practices that Mickey mentioned, like endpoints, is there a list of these that are automatically enabled in our solution? So in the case of MuShop, there are, oops, sorry, my Slacks have started coming back. In the case of MuShop, there is an endpoint that's automatically configured. That is something that you can set yourself if you like. You don't have to set it. You could keep it entirely private, but this isn't something that's required for every single scenario. This just happens to be how this particular solution works. I see there's a question about performance benchmarks. That's probably easier for us to take offline. I currently don't have an answer for you on that, but we do have clusters that are running above 300 nodes, 35K pods and 25K config maps. So we can certainly handle that level of scale and more. But when it comes to performance, it would probably be worth trying to do some sort of POC or test in order to make sure that it meets your expectations. Okay, and then there's a last question on auto scaling of nodes. Can the cluster be set to provision new nodes based on loads? Yes, that was something that if I had a little bit more time, I would have talked more about. You can do auto scaling at the pod level using horizontal pod autoscaler and vertical pod autoscaler. Horizontal autoscaler will add more replicas to your application based on the load, based on CPU and memory utilization, in addition to other custom metrics. Vertical pod autoscaling will do the same, but then it will actually change the resource reservations for particular pods in your cluster. So in that case, it's almost like you're vertically scaling up this very small pod. The other option is using cluster autoscaler, and cluster autoscaler will be, as you just asked, at the node level, and based on unschedulable pod requests, it will scale up nodes. So the nuance there is that unlike horizontal pod or vertical pod autoscaling, cluster node pod autoscaling isn't going to be facing even requests. Like you could have a pod with a very large reservation or a very small reservation, which means that things like CPU load don't always factor in the way you'd expect. But that is something we support. And so I would recommend taking a look at the cluster autoscaler documentation for more information.
Yep, I did share the blog that you wrote, Mickey. So they have it now.
Awesome. Thank you. Cool. Well, if there are any more questions, that's all I have on my end. Greg, did you have any last comments to share?
No. Yeah. Let us. If there's some topics that were not that you would like to deal with in future webcasts, and it's not part of the poll, please put it in the Q&A as well.
Yeah, we would love to have you back. There's tons of questions and lots of engagement. And thank you very, very much, Greg and Mickey and Manish, for a great presentation and answering all the questions. Thank you so much for this presentation. Thank you so much, everybody, for sticking around. If you've got other questions in the future, come join us on the forums and post your questions and take a look for future events. And we will see you next time. Thanks, everybody. Have a great day.